Start.
Good day to our lecturer. Today we want to present about safety and legal requirement for DC and AC electrical machines. First of all, I'd like to introduce myself and my team members. My name is Yokaran Logan. My matrix number is B1124105999. Then Izzat Akimi bin Ismail, B1112410408. And Sailesh Nair Analaki S. Bhaskaran, B1124103996. We are from BLR1/2. Introduction to electrical machine standards. So, objective of this assignment is to identify, analyze, and apply relevant safety, legal, and sustainability standards related to the operation of DC and AC electrical machines. This study aims to enhance understanding of international and national standards such as IEE, IEC, OSHA, and NEC, and to evaluate their importance in ensuring safe machine operation, legal compliance, and protection of workers and the environment. Additionally, the assignment seeks to examine the impact of adhering to these standards on sustainable development, including societal well-being, economic efficiency, health and safety, and environmental sustainability in electrical engineering practices. Second one is impact. Adhering to safety and legal standards in DC and AC electrical machine operation help protect workers and the public from electrical hazards, improve system reliability, and reduce economic losses. It also support environmental sustainability through efficient energy use and promotes responsible and safe engineering practices. This presentation covers key international standards, legal compliance, and practical application scenarios. Key international standards. First, let's look at the IEE and IEC standard. The IEC 60034 series is the main thing of rotating machines. It defines everything from how we label the motor to how much heat it can handle. For instance, IEC 6003430 defines efficiency classes IE1 to IE4. As engineers, we must select machines that meet high efficiency standard to reduce energy consumption, which directly impact the economy and the environment. The purpose of the key international standard is to ensure the technical consistency and performance reliability across global machine application. Safety and workplace standard, OSHA and NEC. Moving to installation, we follow the NEC, National Electrical Code. This is not just suggestion, it's a requirement for how we size the wires and protection devices for motor. For example, if we don't follow the NEC at 430, we risk electrical fires. Finally, OSHA ensures the once the machine is installed, the people working around are protected from arc flash, hazard, and mechanical trapping. Safety is the foundation of all engineering practices. 11. This standard minimizes the risk of fire, shock, and mechanical failure during operation.
Okay, thank you, Yogarma. Myself, I'm Sailesh Nair. I'm going to present legal compliance and regional requirements. While international standards give us the technical, how regional laws give us the legal mass. In Malaysia, the operation of electrical machines is strictly governed by the Electricity Supply Act 1990, Act 447, and the Electricity Regulations 1994. These legal frameworks mandate that all electrical installations, including those involving AC and DC machines, must be registered with the Energy Commission, Suruhanjaya Tenaga. Before a machine can be commissioned, it must undergo a rigorous inspection and testing process to ensure it is compatible with the Malaysian electricity supply system. This legal requirement is in place to protect the public and the economy by preventing technical failures that could lead to widespread grid instability and hazardous industrial accidents. So, furthermore, the regional safety compliance requires that any electrical equipment used in industrial settings must possess a certificate of approval (COA). This certificate proves that the machines has been tested by an accredited laboratory such as SCRIM and complies with national safety standards. Beyond legal paperwork, regional regulations also focus on Sustainable Development Goals (SDG 7 and SDG 9). Engineers are legally and ethically obligated to ensure that machines are not only safe but also energy efficient. Adhering to these regional requirements minimizes environmental impact and supports the national agenda for sustainable and resilient industrial infrastructure. So the environmental impact, ensuring machines operation adheres and sustainable development goals. So next slide. So the next slide is specific safety requirements, AC or DC. Now let's talk about physical safety. The lockout or tagout LOTO system is the most critical life-saving protocol. Before any maintenance on a DC or AC machines, the energy source must be physically locked with the padlock and a tag must be placed. We also must emphasize grounding. In AC machines, a fault in the insulation can turn the motor casing into a live conductor. Proper grounding provides a low resistance path to the earth, tripping the circuit breaker and saving lives. We must also evaluate the sustainable development impacts. An unsafe machine isn't just a health risk, it's an economic risk. A single motor failure can shut down an entire production line, costing thousands of ringgit. By adhering to this safety protocol, we contribute a sustainable economy and help workforce fulfilling our duty to society. So the insulation standards, ensuring electric strength to prevent short circuits and leakage currents. Thank you.
To put this into perspective, let's look at a real world scenario. In this hypothetical scenario, imagine our engineering team starts with the installation and commissioning of 15 kilowatt three-phase AC induction motor. Drive a high capacity ventilation fan in a manufacturing plant. The application of safety and legal standards begins long before the power is turned on. First, the engineer must verify that the motor nameplate contains the IEC 60034 certification, ensuring it meets the required efficiency and thermal rating for continuous operation. We must consult NEC Article 430 to precisely calculate the conductor size and select the appropriate overcurrent protection device, such as circuit breaker, to prevent electrical fire during a stall or overload condition. Once the physical installation is complete, the focus shifts to the operational safety and legal validation. Under the Electricity Supply Act 1990, the installation must be inspected by competent person as registered with the Energy Commission to certify that the grounding system is secure and the insulation resistance is within safe limits. To ensure long-term safety, we implement a strict lockout LOTO station at the motor local isolator switch. This ensures that during future maintenance, the energy source can be physically locked, preventing accidental startup. This systematic approach demonstrate how international standard and regional law works together to create a safe, sustainable, and legally compliant industry environment. As future engineers, we have an ethical obligation. The UTEM rubric asks us to reflect on safety awareness. It is not enough to be technically smart. We must be safety conscious. Choosing a cheaper, non-compliant motor might save money today, but it risks life tomorrow. Our professional integrity is measured by how strictly we follow this safety and legal requirement, even when no one is watching. Thank you for watching and listening.